course of probability and statistics. Now today we should learn about say example of skewness. I am your instructor Mr. Hardik Joshi. So let's move on the topic. So see the example. Say now as we have seen that say movements give the four quantity. Say first one is the skewness. Now again we have to see in the detail there are how many types of the skewness. Now basically we have to say that there are three types of skewness. So no skewness, yeah, sometimes is known as the symmetric curve. The next one is the positive skewness and negative skewness. Skewness is also just simply known as the skew, that is positive skew, and negative skewness, that is negative skew. But in detail, we have to see in this lecture how we can calculate if the data, frequency data is available, then exactly how we can calculate the skewness coefficient. So in this lecture, we have to see how we can calculate that coefficient. So for that, we have to see the example. Say, the question says that find the Karl Pearson coefficient of skewness. Again, I will repeat you. Why is Karl Pearson? Because these are the name of the statistician who gives this a whole procedure. That's why this procedure is known as the Karl Pearson coefficient of skewness. Karl Pearson coefficient of skewness from the given data. Say the number of observation is given. So first observation is say 3, 4, 8, 2, 4, 4, 3, 4, and so on 11. So as you have to see carefully, the only observation is given. Now corresponding frequency is not given. It means the first digit is 3. So only this information is given. Say 3 is present, but it does not give any of the information. The number 3 is occurring how many times. That is corresponding frequency is not given. And we have to study in our schooling level that only observation is given. Corresponding frequency is not given, then this type of data is known as an ungrouped data. So these are an ungrouped data. So in this first example, we have to see if the ungrouped data is given, then how we can find out the coefficient of given by the Karl Pearson. So let's start to find out the Karl Pearson coefficient of skewness. As we have to see in the last lecture, the Karl Pearson coefficient of skewness is defined as or is denoted by say Sk, where capital S stand for the skewness and in suffix k, where suffix k is stand for the Karl Pearson. S for skewness, K for Karl Pearson. So the Karl Pearson coefficient is defined as Sk is equal to mean minus mode upon sigma, where sigma is stand or is referred as the standard deviations. So in another word, we have to say that the coefficient of skewness is nothing is in terms of the measure of standard tendency. Because we know that the measure of standard tendency, that is mean, mode and standard deviations. So to find out or to work with the Karl Pearson coefficient of skewness, ultimately we have to find out the all measure of standard tendency. So to simplify this equation, start one by one, we have to find out each and every quantity which are included in this equation. So our goal is we have to find out, say first one, say mean. The second one is mode. The third one, that is denominator quantity, that is standard deviations. So one by one, you have to see in the detail how we can find out say mean, mode and standard deviation. So let's start the first quantity, and we know that the mean is a very well known measure quantity of the standard tendency. Mean is also known as say average. Sometimes it is also known as say expected value. Yeah, it is also known as mathematical expectation. Yeah, expected value. Because it's too much popular, so there are a variety of names available. But simply here we have to write down say mean. And as we have to discuss, the data is in ungrouped data because the only observation is given say 3, 4, 8, 11 and so on. But corresponding frequency is not given. That's why this data is known as an ungrouped data. And as we have to see in the schooling level, when the data is an ungrouped data, then how we can find out the mean? So mean is nothing but is the sum of all the observations divided by total number of observations. And now we have to define the observation is, say, suppose x1, x2, x3, x4 and so on, xn. So in this case we have to find out the sum, so we have to write down, say, sum of xi, and in denominator we have to write down capital N, where capital N is the total number of observations. Mean is sometimes also denoted by, say, x bar. Yeah, some of the author is denoted by, say, mu. So as per your convenience, either you have to consider as x bar or mu. So to find out the mean, we have to just plug in each and every data in this formula. So our first observation is 3, second observation is 4, third observation is 8, and in same direction the 11th observation is 9, and the last, that is 12th observation is 11. Divide by total number of data, that is observation is given, and is 12. So simply we have to find out the sum of the numerator, and it leads 67 divided by 12. So 67 divided by 12 is nothing but is just the value of the mean. Next we have to find out the second measure of central tendency, that is mode. Now just for sake of convenience, again we have to write down all the data is here. And as you have to see here, we have to highlight the data by different color. What that color represents? See here. Here the number 3 is repeated twice. So we have to highlight it by that green color. The number 4 is repeated 4 times. So we have to highlight it by, say, blue color. The number 8 is repeated twice. So we have to highlight it by red color. And the rest of the numbers are just in one. So we have to write down as a black color. So as you have to see that the number 4 is repeated more times. That's why we have to say that mode is 4. In general, we have to say that mode is nothing but is just a higher frequency. Which of the data is repeated frequently? So we have to say that mode is 4. So next we have to find out the standard deviation. Now standard deviation, as we have to see, the standard deviation when an ungrouped data is given is calculated by using the formula sum of d square upon n, where d is nothing but is just x minus n. What is d? So d is nothing but is the deviation of the data from that mean. That is how much data is deviate from that actual mean. So to calculate, to find out the value of d, we have to prepare a table. Here the first column indicates, or we have to write down all the data is given. The second column represents the deviation, and as we have to see, deviation is nothing is x minus n. So just for, say, first row, for first row, say value of x is 3, and mean just we have to calculate is 67 divided by 12. So 3 minus 67 divided by 12, so it gives negative of 2.583. And the last column is d into d, that is negative minus 2.583 whole square. So it leads to 6.673. In the same manner, we have to calculate the deviation for each and every data, and finally we have to obtain d square. And we are interested to find out the sum. So the last column represents the sum of d square, and when we have to add all the entry in the last column, it gives the 90.916. So just plug in the value in this formula. So we have to get the standard deviation is nothing but in square root 90.916 divided by n, that is 12. And by simplifying that, we have to get 2.752. So ultimately we have to say that we have to obtain all the measure of standard tendency, that is mean, mode and standard deviation. Just plug in all these value in this equation star, and by simplifying we have to say get the value of the skewness. So skewness is 0.575, and as we have to see, if the skewness is greater than 0, then is known as a positive skewness. So in this manner we have to find out the skewness coefficient given by the formula given by the Karl Pearson. Let's see one more example. So find the Karl Pearson coefficient of skewness from the following data. Now see in this table, now if we have to compare with the last example, in last example only observation is given, so that data is known as an ungrouped data. But here the marks is given and corresponding frequency. is given. So this type of data is known as a group data. Now how we can interpret it? Suppose see the first one is say 20. So the first data represents that how many students get 20 marks, so 7. How many students get 21 marks, so 12. And at the last we have to say that how many students, say only one student get 28 marks. And we are interested to find out the coefficient of skewness, that is how much data is skewed in the distributions. So as per the same strategy, to find out or to work with the Karl Pearson coefficient, ultimately we have to find out three quantity: mean, mode and standard deviations. So for group data, say mean is nothing but just sum of fi xi upon sum of fi. So just for sake of conveniency, we have to write down marks as the first column, number of students, that is frequency, as the second column. And to calculate the mean, and as we have to know in our schooling level, when group data is given, then mean is calculated by sum of fi xi upon sum of fi. So it is just nothing, say multiplication of first and second column. And just plug in its value, whatever you have to get in the third column. That is 20 into 7, so 140, 21 into 12, that is 252, and so on. So at the last, we have to find out sum of fi xi, and is nothing but 1831. And the sum of fi, that is the total number of students. So here the total number of students is 80. So we have to get mean is 22.887. Next, to calculate the highest frequency, so see in the table, we have to say that, say 22 marks is getting by the highest students. Say 25 students get the 22 marks, and 25 is the highest in the frequency table. And the corresponding value of xi is 22, so we have to say that mode is 22. Finally, we have to find out the standard deviation. Now the standard deviation, when the group data is available, so is sum of FD square upon n, where n is nothing but is total number of observations. So again we have to repeat first, second and third column is as it is in this column. Deviation, as we have to discuss in previous, deviation is nothing, it's how much data is deviated from its mean, that is d is x minus n. D into d, so it's nothing but the square of d, that is negative of 2.887 square, that is 8.334. And at the last we have to obtain f into d square. So just like say 7 into 8.334, so it leads 58.343. And we are interested to calculate sum of fd square. So it's nothing, just find out the sum of each and every element of the last column. So it leads 311.987. So just plug in all these value in the formula which is given in the top margin. So by plugging that value, we have to get the standard deviation is 1.974. And again, as you have to see, the standard deviation is 1.974. Mean mode we have to calculate, plugging all that value in equation start. So we have to get the coefficient of skewness is 0.449. And again we have to say that 0.449 is greater than 0. So these are the positive skewness. And now in this slide, just we have to represent whatever we have done in this whole lecture by this graphical interpretation. Now this graph suggests that the number of students versus the marks obtained. And if you have to observe carefully the graph, then from this graph we have to say that these are the positive skewness because there is a tail, it's a right tail on the right hand side. So again I have to say that if you know the behavior of the graph, then you have to also predict which type of skewness is. So thank you.